Whoa. Welcome, guys. So in this video, we are trying to solve. I'm trying to solve these probability problems. Okay, so this problem is famous that maybe if you like go to some quant interview or basically the college probability. Okay, and I will present two methods, and both are very easy. So I hope you guys can understand. Before I start, please subscribe to my channel. Okay, so the problem is that roll two dice for infinite times, so the probability that you get a sum of 4 before a sum of 2. So some people like to ask for a sum of 6 before a sum of 9, or a sum of 9 before a sum of 6, or a sum of 10 before a sum of 2. Okay, so you can change. Okay, so the method 1 is like the recursive way. Okay, so let's say, so before we start, let's count how many we can get 4, right? So we get 4 means that we get 3, 1. Or we get 2, 2, or we get 1, 3. So this gives a 4. And if we get 2, 2, we get sum of 2, right? There's only 1, 1, 1. Okay, so it's 2. Okay, so the probability, the sum is 4, is basically 3 over 36, right? Because total is 6 times 6. And the sum of 2 is basically 1 over 36. So recursive way is that we start from trivial one. So in the first round, there are 3 possibilities that you get sum equals to 4, sum equals to 2, or others. Okay, so the probability, let's say, is P equals to, the first one is that in the first round, if you get 4, then it's very lucky that you're very lucky. And there's a chance that you get 2, right? But if you get 2, then it's over, right? You cannot get nothing. And the third contribution is others. Sorry, so others is 36 minus 3 minus 1. Okay, so if you get others, then you get us into a second round. Okay, but so it's the same, right? So each times P. This is the second round. The second round, you get 4 before 2. Right, so this is the first round, you get 4 before 2. So this is a linear equation. So we got P equals to 1 over 12. This is what? 38 divided by 36. So it's 8 divided by 9 P. So we get 1 over 9 P is equal to 1 over 12. So P is 3 over 4. So it's 0.75. 0.75. Okay, so this is the so-called recursive way. Okay, let's talk about the amazing method 2. Okay, the amazing method 2 is very easy, right? If you see that this graph, right, you get 3, you have the 3 chance. So average that in average, you have 3 ways to get 4, and you have 2 ways. You have 1 ways to get 2. So in average, the prob. You get 4 before 2 is just 3 divided by 4, right? Because you total have 3 ways to get 4, and then you have 1 ways to get 2. So the answer is 0.75. Okay, so one might ask that is it coincidence that these 2 methods give the same answer? The answer is no. Okay, so now I want to prove. So I want to prove method 1 always the same as method 2. I should say equals to method 2. Okay, so this is very naively proof, right? Suppose that you have some results that x equals to a, that this is PA, and then you get px equals to b equals to bb, and a, b are independent. And I want to ask that whether what's the probability I get let's say what's the prob I get A before B. Okay, I should say A before B. Let's say this is P. Okay, so from the method 1, we know the answer is P equals to PA plus, if I didn't get A or B, I get 1 minus PA minus PB times P. Okay, so solve this, we get PA plus PB equals to PA. So this is P just PA divided by PA plus PB. So this is the same as method 2. Okay, so yeah, that's it. So in this case, now if somebody asks you the same question, you can use just this answer, right? So PA just 3 plus 1, 0.75. Okay, so when I first see this question, I used the method 1 to solve it because I'm not smart enough to prove that method 1 actually the same method 2, right? But once I solve this problem so many times, then I figure out that method 1 is the same as method 2. So you don't need any like the recursive idea or the smart idea. You only need to use the very naive way that there are 3 ways to get 4 and then 1 way to get 2, right? So the probability that you get 4 before 2 is just 3 divided by 4 is 0.75. Okay, so hope you guys hope this helps you guys, and be sure you subscribe to my channel. Thanks.